Welcome back. So far, in this video series, we've been talking about limits to infinity approaching horizontal or oblique asymptotes. But what we know is that graphs also have vertical asymptotes. And oftentimes, the directions that we are headed to on either side of that vertical asymptote go in the opposite direction, as you can see in this picture. Okay? So we have a definition for dealing with vertical asymptotes. So our definition here says that if we have a line, x equals a, representing a vertical asymptote, all right? So we have a vertical asymptote at a. If we look at x approaching a from either the right or x approaching a from the left, we know that the function is either going to go to positive and negative infinity. In this case, our function is y equals 1 over x. If we were to look at the limit as x approaches 0, because we have a vertical asymptote at x equals 0. So if we look at the limit as x approaches 0 from the right, as x approaches 0 from the right of that function, where does my graph go? So as we go towards 0 from the right, the graph is going to go to positive infinity. And if we also look at the limit as x approaches 0 from the left, and I'm noticing I've written an x up there where I need a 0, so 0 from the right. As x approaches 0 from the left of that function, so going towards 0 from the left, the graph goes down forever. We would say negative infinity. And as a note, you don't have to write plus in front of the infinity. If it's not signed, we assume it's positive. I'm writing it in this case for emphasis. So when we're dealing with vertical asymptotes, essentially you just need to consider the behavior on either side of that asymptote. So let's look at an example. So in this situation, we're going to look at the limit as x approaches 3 from the right of the function 1 over x minus 3. And of course, we can see, looking at this, there's a vertical asymptote at x equals positive 3. All right, so we are approaching 3 from the right. So that essentially means I'm plugging in a number that's slightly larger than 3, such as 3.1, right? That is on the right side of 3. And really the easiest way to do this is to just look at the sign. So if I were to think about plugging that in, that would give me 1 over 3.1 minus 3. So 1, that's a positive number in the numerator. 3.1 minus 3 would still be a positive number. So positive over positive, because they're both positive, we would say this goes to positive infinity. And if we were to consider that graph, again, it has a vertical asymptote at positive 3. We have a horizontal asymptote at 0. The graph looks roughly like this. So as x is approaching this, there's x equals 3. As we approach 3 from the right, where does my y value go? And it goes to positive infinity. So when you're doing these problems, if you get the same sign in the numerator and the denominator, plus plus or minus over minus, it's going to go to positive infinity. And if you get different signs, a positive over a negative or a negative over a positive, you will get negative infinity. And if we were to take this a little bit further, we'll say part B of this problem, and I say find the limit as x approaches 3 from the left of that same function, 1 over x minus 3. So 3, approaching 3 from the left, if this is 3, something on the left side might be 2.9. So if I looked at that 1 over 2.9 minus 3, I would get a positive value in the numerator, and 2.9 take away 3 would be negative. Positive over negative, in this case, we would say this goes to negative infinity. It's hard for me to cram in there, but negative infinity would be our answer in that situation. So really, it's just about looking at the left and right side of the graph. And continuing that thought, what could we say? We'll say part C. What can we say about the limit as x approaches 3 of that function, 1 over x minus 3? And because the right hand and the left hand limits are not the same, we would say that this limit does not exist. Because remember, in order for a limit to exist, the left side and the right side need to go to the same value. If the left hand limit and the right hand limit match, then we know the general limit. All right, we'll look at one other example here. In this example, we're going to find the limit as x approaches negative 5 of 3x divided by 2x plus 10. So we are dealing with a rational function here. And if we look at the denominator, what happens when we plug negative 5 in for x? 2 times negative 5 is negative 10 plus 10. We would get 0, right? So we end up with, if we were to try and evaluate that, we would get negative 15 over 0. We're not allowed to divide by 0. This is what we call an indeterminate form, and we'll learn more about that when we know about derivatives. But we can't divide by 0, so we cannot just evaluate it. And why, or what does that mean, having 0 undefined in this function for x equals 5? That means if we were to look at the graph, we would see at x equals negative 5, we have a vertical asymptote. All right, so we don't know what's happening on either side of that asymptote. And since this is a two-sided limit, right, or just the limit from both directions, we would need to do this maybe in two parts. So I would look at this, say part A, the limit as x approaches negative 5 from the left of 3x over 2x plus 10. So negative 5 from the left, if this is negative 5, from the left, we might have a number like negative 6. All right, so what happens here? If I were to plug in negative 6, I would say 3 times negative 6 over 2 times negative 6 plus 10. And that would simplify to negative 18 over negative 12 plus 10, negative 2. So in this case, because I have negative over negative, I know that this goes to positive infinity. All right? So because I've got negative over negative, so that means my graph, as we approach negative 5 from the left, it's doing something. It's got a horizontal asymptote at 3/2. Let me draw that in here. We've got y equals 3/2. My graph is going up to positive infinity. So let's look at the other situation here. So the other situation would be looking at the limit as x approaches negative 5 from the right of that function. So if we're going to do that, we're saying, okay, well, we are going to negative 5, and from the right side approaching negative 5, that could be a number like negative 4. So if I were to plug this in, I've got 3 times negative 4 over 2 times negative 4 plus 10. 3 times negative 4 is negative 12. 2 times negative 4 is negative 8. Negative 8 plus 10 is positive 2. So in this situation, I have negative over positive. Negative over positive means that my limit in this situation is going to go to negative infinity. All right, so I have two limits. I have a left-hand limit, positive infinity, and a right-hand limit, negative infinity. And since these two limits do not match, we know that the limit of this function does not exist. Now, if I were to continue looking at the graph, I would see something that looks like this. So the limit as x goes to -5, since the left and the right don't go to the same side, my answer here would be does not exist. There is no limit. And just to recap a little bit, because I know I didn't formally define my rules for looking at the left and the right side. So when we are looking at limits and we have a vertical asymptote, all right, you're going to choose a number slightly to the left or right, depending. All right, slightly to the left and or right of that vertical asymptote number. And you're going to evaluate it in the function. If you get positive over positive or negative over negative, then that means the limit as x is approaching whatever your number value is, that limit is going to approach positive infinity. And if you end up with negative over positive, opposite signs, or positive over negative, then that limit of whatever number you're approaching is going to go to negative infinity. All right, so I hope that helps. Let me know if you have any questions.